Hello to everyone. For today's lesson, we are going to discuss about chords and arcs. So let us study this figure in relation to our topic. We have circle O, so that is the name of the circle. Then we have a chord segment AC. If OB is perpendicular to AC, which is the chord, then OB bisect AC. Similarly, if OB bisect segment AC, then OB is perpendicular to AC. In this case, B is the midpoint of the chord AC. In this figure, we have circle O. If line BD is a perpendicular bisector of chord AC, then line BD passes through at point O, which is the center of the circle. How about this figure? This is circle O. If OB is perpendicular to the chord AC, then segment OB bisects angle AOC. So when we say bisect, it divides the angle into two equal parts. So they are congruent. Let's try this example. Question number 1 about chords and arcs. In circle O, so we are referring to this circle, OB is perpendicular to AC. If OA equals 20 cm, so we will label this is 20 cm. And angle AOC is 100 degrees. Angle AOC, so this angle. How far is the chord? So the chord is segment AC from the center of the circle. So the center of the circle is O. Now, since we have OB is perpendicular to AC, we have a right triangle here. The measurement of angle AOC is 100. So this is now a bisector, so it means angle AOB is equals to 50 degrees. So this is equals to 50 degrees, then this is also equals to 50 degrees, angle COB. The question now, how far is the chord? So starting here until point O, so the center of the circle, we are going to find this. So in a triangle, in any triangle, the sum of the interior angles is equals to 180 degrees. So we have 90 plus 50 equals 140. So subtract it from 180, angle A will be 40 degrees. And if we will add 40 plus 50 plus 90, so the total is 180 degrees. We can apply here the trigonometric function to find this distance from point B to O. So we have, with respect to this angle, we have the opposite side over the hypotenuse opposite over hypotenuse. Are you familiar with the SOHCAHTOA? Okay, opposite over hypotenuse is sine. So sine 40 degrees is equals to, let's say this is OB because we are looking for that. So that is the distance from the distance of chord from the center of the circle. So over 20. Then cross multiply OB is equals to 20 sine 40. Then we are going to use now the calculator. So we have 20 sine 40 degrees is equals to 12.86 approximately. So 12.86. So this is now the distance, okay, from the center of the circle, okay, from chord to the center of the circle. So this is the answer. 12.86. What is the unit? cm. Let us answer now question number 2 of chords and arcs. In circle O, we are referring to this figure with radius of 24 cm. So the radius here is segment OA. So this is 24 cm. The chord is 12 cm from the center. So the chord is segment AC. So the distance of the chords from the center is 12 cm. So this is 12 cm. How long is the chord? We are going to find the length of from here until here. Then from the given, by inspection, you will notice that there is a right triangle. We have triangle ABO. So the right angle is here. So this will be the hypotenuse. So to find AB, we are going to use the Pythagorean theorem. Then once we get it, the value of AB, we just simply multiply by 2 because OB is perpendicular to segment AC. Then at the same time, OB bisect segment AC. So therefore, AB is congruent to segment BC. So let us show the solution. We have now AB squared is equals to AO squared minus OB squared. So substitute now 24 squared minus 12 squared. So we have AB squared here. Then 24 squared, we can use the calculator. 24 squared is equals to 576. 576 minus 144 is equals to 432. So we have AB squared here. To find the value of AB, we just simply apply square root property, squaring both sides of the equation. So cancel this. We have now square root of 432 is equals to 20.78 approximately. 20.78. Then this is the value of AB. Since the question is how long is the chord, we have now AC is equals to AB times 2. So it's equals to 20.78 times 2. So AC now, which is our chord, 20.78 times 2 is equals to 41.56 cm. So this is now the length of the chord. How long is the chord? So the answer is 41.56 cm. Let us answer question number 3. Find the length of a chord in the inscribed equilateral triangle. So this is equilateral triangle, triangle ABC. So meaning all the sides, the 3 sides have equal measurement. Then an equilateral triangle is also an equiangular triangle ABC with the radius of the circle is 24 cm. So let us label the figure here. So the center is point O. The radius will be, so this is equals to 24. We will use this side cm, or we can also use segment OB or segment OC. So they are congruent. Now this is equals to 24. Then this is 60 degrees, 60 degrees, then 60 degrees. So it will become now 30 degrees, 30 degrees. Because we have the line here, AO, bisect angle CAB. So since that is 60 degrees, divide by 2, so it will become now 30 degrees, 30 degrees. And then we are going to look for the chord. Okay, find the length of the chord. So we will find the length of the chord. So if we are going to look the length of this, so what will be the length of this chord? AC. Now from that we can, if we will draw here, so let us draw a bisector also here. We just make this straight, then also here. Okay, so this is this will form now a right angle. So we bisect this chord AC, so it will form a right angle. So this is 24. So we can find this. Let's say we assign here, this is point D. So we are going to solve for segment AD because this is given now 24. So we have a right angle here. So with respect to this angle 30, so we are looking for this. We have adjacent over hypotenuse. So using the SOHCAHTOA, adjacent over hypotenuse is cosine. So cosine 30 degrees is equals to AD over 24. Then cross multiply, AD is equals to 24 cos 30 degrees, cosine 30 degrees. So let us use the calculator. So we have now 24 times cosine 30 degrees is equals to 20.78 centimeters. Then since we have a perpendicular bisector here to segment AC, to find AC, which is the chord. So we have now AC is equals to AD times 2. So we have 20.78 times 2. So it's equals to 41.56 cm. So this is now the answer in question number 3. Your activity is practice and application. Answer Roman numeral number 1, find the value of x in its figure. And Roman numeral number 2, find the indicated measures. Use the figure on the right. So that is page 181 and 182. Number 1 up to 20. So until number 20. Write your answer in your notebook. Show your complete solution. Thank you.